Hi, everybody. In this new unit, we're going to be talking about two different types of equations. We have always graphed in terms of x and y, right? It's called a rectangular equation. The two new types of equations we'll be graphing with either won't have an x and a y, or they'll have an additional variable that we will then graph in. So what we're going to do first is we're going to look at what's called parametric equations. And you all worked with parametric equations yesterday as you saw the ants scurrying around the screen. So that's why I kind of put some ants on the top of the page of your notes. That way you can say, oh yeah, this is the ants. Right? Now with parametric equations, it's not about what the graph looks like when it's done. It's about how the graph is being created. It's about the time that's passed to create this graph. So we have this third variable called a parameter, which is t, and that typically represents the amount of time that's passed. So at 1 second, I can see the position of the graph, or at 2 seconds or 3 seconds, and I can see how the graph changes. So the parameter is t, it's our third variable. Parametric equations come in two pieces. We don't just have a single equation anymore. We'll have both an x equals equation and a y equals equation that work together to create that one graph. And then both the x equals and the y equals equations will have the variable t in them. So that's how parametric equations work. It'll say x equals, y equals, well, they'll both have a t, but together they make one final graph. So we would consider that a parametric equation, all right? So when we go to graph a parametric equation, if we're going to do it by hand, we're really just going to set up a t-chart. T-chart, right? We're going to set up a t-chart, plot points, and then as we plot these points, we'll have to make sure that we either remember the order that we plotted the points, or we'll draw arrows as we do it. Because again, it's all about the direction and how this graph was formed. Okay, it's not just the final result. So I'm going to scroll here. I have an example here. I would like to graph this equation that says x equals t squared minus 4 and y equals t over 2. And I've given you values of t that we're going to use, which are from -2 to 3. So I'm going to set up my t chart, and then we'll plug in values of t that will determine x and y, and then graph those. Now, when I set up my t chart, I usually do it horizontally because I don't want to take up all the space to go with a vertical t chart. So I'm going to go set up my t chart. So I need there we go, there's t. So I need something for t, we'll need a value for x, and we'll need a value for y. So it's even bigger. That was really crooked, I gotta fix that. It's even bigger than normal, right? Okay, so I have given you values of t that I would like you to use, and that is from -2 to 3. So I'm gonna go ahead and fill those in for t. So -2, -1, 0, 1, 2, 3. Might have to extend these lines a little bit. There we go. So let's plug those values in to the x and y equations, and that'll give us the values of x and y. All right, so if t equals -2, x equals t squared minus 4. So -2 squared minus 4 would be 0. 0. 0 doesn't want to write. There it is, 0. And then if I plug -2 into the y equation, then I get -2 over 2, which would be -1. So at time -2, we have an ordered pair of 0, -1. All right, and that's what we'll end up putting on the graph. I'm going to go ahead and get my chart done first, and then I'll plot the points. So when t is -1, I can plug a -1 into both of my equations. I would get 1 minus 4, so -3 for x, and -1 over 2, or -1/2 for y. Then we'll keep moving on. So when t equals 0, I would get -4 and 0. When t equals 1, I would have -3 and +1/2. When t equals 2, I'd have, 0 and 1. And then when t equals 3, I'd have 9 minus 4 is 5, and 3 over 2. All right, so again, for each of these, I'm just taking this t value, plugging them into the x equals equation and the y equals equation, and creating these ordered pairs. So now as we go to create our graph, we're just going to plot these ordered pairs, so just x and y, and then we'll use an arrow to show the direction that t is changing in. So when you look at the graph, you're not going to say, hey, t was this value. It doesn't show up on our graph because our plane is just in terms of x and y. So we have to show the value, or how the value of t is changing, just by using arrows. Okay, so I'm going to go ahead and plot my points. 0, -1 would be about right there. That was my original starting point. And then it went to -3, 1, 2, 3, -0.5. Something there, if I can get it in there. Okay, close enough. And then it went to -4, 0. And then -3, +0.5. Trying my best with my fat pen and my little graph. What was I? -3, +0.5 did that. So 0, 1. And then 5, 1, 2, 3, 4, 5, 3/2, something like that. So there are my points that I plotted, that I created using this, this chart, right? And now I connect them. Again, I'm going to connect them in the same order I graphed them in. So I'm going to start at this bottom one. It kind of went out to the left. If I can do that. There we go. And then circled around. And then I'm going to show that order, because if I just gave you this graph, you wouldn't know where I started, right? So I'm going to show the order by just putting little arrows on here. I'm actually going to zoom in. I probably should have done this. Oh, look how much nicer that is. So I'm going to go ahead and put some arrows on here. So just showing the direction that I plotted these points, I can see how t has changed, where it started, and then which direction the graph went as I plotted my values of t. All right, so this is what a parametric graph looks like. Can you see that it's not a function? If I try to do a vertical line test, it fails pretty miserably, right? Look at all those. So these are not functions. Let me get rid of those. These are called parametric equations. They're not defined as functions anymore. We've left behind function world. Okay, so moving on. We can graph these on our calculator. Let me go ahead and pull up my calculator real quick. You've already done some graphing in Desmos, I think, but I will go ahead and talk through that real quick. But I did want to show you how you can do them on your calculator, although I feel like you did them in your calculator for the ants, if you remember that. So I just want to check to make sure we are in the correct mode to graph this on our calculator. So, come on, calculator. It's thinking. There it goes. Okay, so I don't want to automatically check. Close. Okay, so the important thing on our calculator is getting to the correct mode. Oops, I guess I need to do this. Because typically we graph things in function mode. If you go to mode on your calculator, you will see on mine, it's right under radians and degrees. I'm in function mode. So that's why we just do the y = 3x + 5 or whatever, right? What we want to do is change our mode to parametric. On some of the older calculators, it just says par. So if you see par, that's what we want. Mine, I can see it says parametric. So now when I hit enter, I'm in parametric mode. If you go to y =, you see it changes. It doesn't say y = anymore. Now you can see the pairings of x and y to create those parametric equations. All right, so I'm going to go ahead and throw this, what was the original equation? T² - 4. Now, where am I going to get t? Because I need to do this in terms of t. It's not x anymore. Because we've changed the mode to parametric, when you hit your variable button, which is the one right next to the alpha, it now shows up as t. So that button adjusts to what mode you're in. It's typically x if we're dealing with functions, right? But now that we're in parametric mode, it's t. And then we're going to see how that will again change when we do our next type of equation. We won't be in t anymore. So anyway, so x was t² - 4. The y was just, was it t/2, I think, right? When you go to your window, you don't just have x min, x max, y min, y max anymore. You also have t min and t max. So I'm going to adjust that to match what we graphed, which was -2 to 5. And then when I hit graph, look, there it is. Now, there's a problem with this graph, is that it went so quick. Like, I didn't have a chance to see where it started and where it stopped. Good thing is it looks like our graph, but I would need to know the direction of this. So in your calculator or in your window, what's adjusting or what determines how quickly the graph will graph is the t step. How often do we want it to plot a point? The bigger this t step is, the bigger this is, the faster it's going to go because it's going to plot less points. So if I want to slow this down, and I think this was part of the ants question, right? Or ants activity. If I want to slow this down, I need to make this t-step smaller. So I'm going to try like 0.05. Let's see what that looks like. And then when I graph, hopefully you saw it went a little slower. If I want it even slower than that, I can make it 0.01. And we'll see that thing really slow down. Look at that. All right, so to change the speed of your graph, you can adjust that t-step. Smaller numbers will make it slower because it's going to plot more points. So that's how we can graph on our calculators. Just change your mode to parametric. Just don't forget to change it back to function when you need it to be in function mode, right? Okay, to graph on on Desmos, Desmos doesn't have a setting for parametric. You can't just do x equals and y equals. So instead on Desmos, we'll type in our x equation and then our y equation really in the form of a set of coordinates. So it'll look like an ordered pair. So if we were doing this previous one, I would do t squared minus 4, right? And then comma t over 2. And that's how I would type it in on Desmos. And Desmos knows, oh, this is parametric. I'm graphing in terms of t. It might even give you an option, I think it does, to set up your values of t that you want to use, etc. All right? Okay, so we are going to have to do some conversions. Let's say we have a parametric equation, but we want to write it in a rectangular form. We want to go back to plain old x and y. We want to see a function notation, or as close as we can get. Two things you're going to do that are pretty super easy. The first thing is I want you to go ahead and solve for t. I would suggest you do this in the x equation, if possible. Equation. There we go. So we're going to take our x equation, we're going to solve it for t. And then once we have an expression for t, we'll substitute that into the y equation. My goodness. Okay, so take your x equation, solve it for t. You'll have t equals whatever, and then plug that whatever into the y, and you will now have a rectangular equation. So this next one I gave you is kind of messy. I think maybe we'll do it in class tomorrow. I just want you to have those steps down. All right? And then the last thing is, oh, we'll do the next one too, because it's really fun. Hey, look, sine and cosine. Yes, they never go away, people. Okay. The last thing I want to do is the reverse. What if you have a rectangular equation, so something just in terms of x and y, and we want to write it as a parametric? We want to introduce a factor of time. Here's what you're going to do. You're going to set up your, remember we're doing an x equals into y equals. Your first equation, I would suggest you just say is x equals t. Force x to represent time. And then all you're going to do is rewrite your y equation. Oh my goodness. In terms of t. Really? Come on. Let's see if we can make this. If we make it bigger, does that help? A little bit. There we go. Okay, so we are forcing x to represent time, and then we can just say, okay, then y equals whatever it is. Instead of x, we're putting in t. Now, what's kind of funny is there's actually an infinite number of parametric equations we could write. I am just asking you to write the simplest one, x equals t. We could also say x equals t minus 1, and then substitute that in. I could say x equals 5t squared plus 3t minus 7, and then substitute that in. You can choose whatever you want to represent your x equation, but saying x equals t is the easiest one, and it's going to give you the simplest answers. So, for example, if I have the rectangular equation y equals 1 minus x squared, I almost gave it away. I want to write this as parametric. So all I'm going to do is say, okay, x equals t. There's my time. There's my x equation. And then y equals, instead of 1 minus x squared, I can say it's 1 minus t squared. And there it is. It's now parametric. We're going to get the exact same graph. We've introduced time. We can adjust the time as necessary, and we're done. So that is a quick view into some parametric equations.